Welcome back, students. In previous video, you have learned various operation on matrices. Addition of matrices, subtraction of matrices, multiplication of a matrix by a scalar. One more operation is left. That is multiplication of matrices. We will be doing that in our next class. Now, I am switching to another topics of matrix, that is properties of matrix addition. Properties of matrix addition. It says the following laws hold good with respect to matrix addition. That is, following are the properties, those are satisfied while adding two or more matrices. The first one is closure property. Second one, commutative property. Third one, associative property. Fourth one, existence of additive identity, also called identity property. The fifth one, existence of additive inverse. The first property, closure property. It says if A and B are two matrices of the same order, then their sum A plus B is also a matrix of the same order as that of A or B. Let's learn this property with an example. Here, a matrix A is taken with 2 rows and 2 columns. And B matrix is another matrix taken with the same order, 2 by 2. Both of them are of same order. So let's add it. A plus B. While adding, the corresponding elements will get added like this: -3 plus 4, 5 plus 0, 6 plus 2, and -1 plus 8. And the result is here: 1, 5, 8, 7. Again, a matrix is here. So result of A plus B is again a matrix which has the same order as that of A or B. So this is the closure property. Another property, commutative property. It says if A and B are two matrices of the same order, then A plus B equals B plus A. Let's make it clear by an example. Here, A and B are two matrices taken. They are of same order. 2 by 2 matrices are taken. Let's verify it. So, starting from left hand side, we are adding A plus B. Matrix A and matrix B are getting added with its corresponding element addition. Look here, 2 minus 4 added here, 5 plus 0, 3 plus 2, -1, -6. Result is here, -2, 5, 5 and -7. This is the result of A plus B. Now to verify it again, we work with right hand side, that is B plus A. We add matrix B with matrix A. Their corresponding elements will get added like this. Result is here. Both the result are same. So it is verified that A plus B equals B plus A. This is called the commutative property of matrix. Moving on to another property of matrix addition. This one is associative property. Here it says, if A, B, C are matrices of the same order, then A plus B plus C equals A plus B plus C. Let's verify it by an example. Here we have taken 3 matrices. All of them are of same order, 2 by 2. To verify it, let's start from left hand side. That is A plus B plus C. Here, B plus C must be added first. So let's add B plus C first, then only its turn of A. Adding B plus A, we are adding here their corresponding elements. 1 plus 9, 8 plus minus 3, 0 plus 7, and minus 6 plus 5. Then simplify B plus C is here. Now it's turn to add the result of B plus C with A. Then we get the result of A plus result of B plus C. Then the final simplified result is here, which is again a matrix. So left hand side we worked. To verify this associative property, again we are working with right hand side. That is A plus B plus C. Here A plus B must be added first. So we are adding A plus B first. Then only its turn of C, A plus B. Their corresponding elements are added like this: minus 2 plus 1, 5 plus 8, 3 plus 0, 4 minus 6. They are added. Then C, copy it as it is. Simplified form of A plus B is here, and then C. Now we are adding the result of A plus B with C. Here it is added. Corresponding elements are added. And final result is here. A plus B added to C. 8, 10, 10 and 3. Here left hand side and right hand side both are equal. That is result of A plus B plus C and A plus B plus C, they are equal. Hence it is verified that A plus B plus C equals A plus B plus C, which we call it as associative property. Now moving on to another property of matrix addition. It is existence of additive identity, which is also called identity property. It says if A be any matrix and 0 be the null matrix of the same order as that of matrix A, then A plus 0 equals 0 plus A equals A equals A. Here 0 is called additive identity of the matrix. Let's take an example. A matrix is here with 2 rows and 3 columns. And let us take 0 matrix, null matrix of the same order, 2 rows and 3 columns, like this. 0 matrix is here. All the elements are 0. It is a null matrix with a order 2 by 3. To verify the existence of additive identity, let's start from left hand side of this equation. Here, I mean identity. Left hand side of this identity, this is an identity. So we are working with right hand side of this identity, that is A plus 0, which equals matrix A added to matrix 0. Their corresponding elements get added like this: 5 plus 0, 6 plus 0, 1 plus 0, 7 plus 0, 3 plus 0, and 8 plus 0. Now we have the result matrix A. Again, to verify this property, let's take the middle part of this identity, that is 0 plus A. We are adding matrix 0 with the matrix A. Their corresponding elements get added and result is again A. Hence, it is verified that A plus 0 equals 0 plus A equals A. Here, 0 is called the additive identity of the matrix. Now, moving on to the last property of matrix addition, that is existence of additive inverse. It says, for a given matrix A of any order, there exists a unique matrix minus A such that A plus minus A equals minus A plus A equals 0. To verify this property, again, let's take example. Example 8. A matrix is taken with 3 rows and 2 columns. Matrix A is here. Matrix A, it is here with 3 rows and 2 columns. And here we have found minus A also. Minus A is here, minus and matrix A. Matrix A, all the elements of this matrix A multiplied by this minus, we have this matrix. So this is the matrix minus A. Now we have matrix A as well as matrix minus A. To verify it, let us start from left hand side again. Left hand side, A and minus A will get added here. A matrix and minus A. Their corresponding elements will get added like this: 5 minus 5, 7 minus 7, 4 minus 4, 3 minus 3, minus 2, plus 2, minus 8 and minus 8. They are added. The result is null matrix, 0, 0, 0, 0. Null matrix, it is 0. To verify it again, let's work with middle part here, minus A plus A. That is matrix minus A and A are getting added here. Their corresponding elements will get added like this. Result is here. It is again a null matrix. And the null matrix is same order as that of A. So here are the 2 lines mentioned. I am reading it here. The null matrix is there that is of same order as that of A, and here the matrix minus A is called the additive inverse of A. Matrix minus A is called the additive inverse of A. So hence it is verify that A plus minus A equals minus A plus A equals to 0. Here, this minus A is called additive inverse of A, and here 0 is the null matrix of the same order as that of A. These are the properties of matrix addition. Now, we will discuss one more topic of matrix, that is transpose of a matrix. It says if rows and columns of a given matrix A are interchanged, we get a new matrix which is called the transpose of matrix A. It is denoted by A dash or A transpose. If the order of the matrix A is m by n, then the transpose of A will have the order n by m. The example is here. A matrix is here. A with 2 rows and 3 columns. A matrix is here. Then A transpose is here. Look, A has the first row 3, 7, 9. Now it will interchange to a column. First row to the first column. 3, 7, 9. First row in A transpose, it will become the first column. A has the second row 8, 5, 1. This second row will interchange to the second column. So look students, here rows are changed into the column and columns are changed into the rows. 3 by 8 here, 3 and 8, they are the first column here. Now in A transpose, it becomes a row, 3, 8, it is a row. In the second column, there are the elements 7 and 5. Now it becomes the second row, 7, 5. The third column, 9, 1, becomes the third row. So, if rows and columns of matrix is interchanged, then it forms a new matrix, it is transpose. Look here, its order is 2 by 3. A has the order 2 by 3 and A transpose has the order 3 by 2. So this is a transpose of matrix. To make these topics clear, let's do few numerical examples here. Workout questions are here. The question number 1. If 3 matrices are given A, B and C, find A minus 2B minus half of C. So we will solve it here. Solution. We have to find this part, A minus 2B minus half C. So we are substituting the values for the matrix A, matrix B and matrix C. Now what we do is matrix A copied as it is, minus also copied as it is. We are going to multiply the matrix B by 2. Be very careful students, we are not multiplying by minus. Minus is the operator between these two matrices again. So we are multiplying this matrix by 2 only. So 2 multiplied to 2, 3 multiplied to 2, 4 multiplied to 2 and 0 multiplied to 2. Minus sign as it is outside. Same here. In the third term, the matrix is multiplied by only 1 by 2, minus remains outside. So 2 multiplied to half, 0 multiplied to half, 0 multiplied to half and 2 multiplied to half. Simplify these things. Now you will get this much. Now we will perform matrix addition or subtraction to all these terms together. That is corresponding elements of these matrices operated together. Minus 8, 4, minus 1, 2, minus 8, 0, minus 0, 7, minus 6, minus 0, and 5, minus 0, minus 1. So this is the result. One more numerical example. It is here. Additive inverse of a matrix. This one is given here. Find the value of x and y. If we read the question thoroughly, matrix is also given and its inverse is also given. So when we list it here, matrix A is given. Here 2, 5, minus 4 and 1. This is matrix A. And if matrix A is given, we can find matrix inverse of A minus A. That is minus A. The value is given here. This much. This is minus A. Additive inverse is given here. That is minus A is also given there. Minus A is additive inverse actually. Question is giving you the additive inverse. That is minus A. We have calculated here. But by question, according to the question, additive inverse of A is given here. This much. Additive inverse of A minus A we have calculated here. So we have substituted the value of additive inverse from here. In place of this one, we have substituted here. This is equals to, and it is copied. Now equating this line, this much we have substituted from equation 1, line number 1. Now equating the corresponding elements of equal matrices, we have x is minus 5 and y is 4. In this way, we solve the numerical problems. Okay, students, this much for today. Your homework is uploaded there in homework section. You have to submit your homework by 26 Jester 2077. You have to do all the works, all the solution in your notebook, and you can submit it in 3 ways. Either you can post it in eMeda's homework section, or you can send it to the email address as mentioned earlier, or you can bring it to the school after the lockdown when the school resumes. Okay, students, thank you. Stay safe, stay healthy.